Okay then, so for this question then, we've got to prove that sine 2 theta all over 1 plus cos 2 theta is identical to tan theta. So to do a trig identity, what I want to do is certainly write proof, okay, down, and select one of the two sides. And for this, I would go for the left-hand side, purely because it looks more complicated and it's generally easier to reduce multiple angles down to smaller angles. So we'll start with the left-hand side. Now you could write LHS, left-hand side is identical to, or you could just copy this down. I generally like to copy the identity that I've got to prove down, so I'm going to do that. Sine 2 theta all over 1 plus cos 2 theta. Now, what I know is tan theta is sine theta over cos theta, and when it comes to working out the top here, sine 2 theta, we've got to think of the standard identity sine of 2a. Sine 2a, hopefully you remember, is 2 sine a cos a. And you can see that the a is just the theta. So we can change this to 2 sine theta cos theta. Now when it comes to the bottom though, okay, the cos 2 theta, what does cos 2 theta, what is that identical to? Well, again, we should know our double angles. Cos 2a. Cos 2a is primarily cos squared a minus sine squared a. And I wouldn't really want to use this here, purely because we've got a mixture of terms, sines and cosines. Knowing that tan of an angle is sine over cos, it kind of makes me want to put cosines underneath here if I can. And you should know that this identity, if we replace sine squared a with 1 minus cos squared a, remember the identity sine squared plus cos squared of an angle equals 1, okay, we can replace sine squared with 1 minus cos squared, and when you simplify this you end up with 2 cos squared a minus 1, an identity that you should know. And it's this that I would want to use. And you can see that, looking ahead, can you see that this 1 is going to cancel out with this minus 1? It's going to give us 0. So that's why I'd be prompted to use that one. Well, we'll put the 1 in anyway, so that'd be 1 plus, and then in place of cos 2 theta, 2 cos squared theta though, minus 1. So just write that in, 2 cos squared theta minus 1. So the 1 take away 1, well that gets to 0, so what we've got is 2 sine theta cos theta all divided by just the 2 cos squared theta. So we've got one term on the top made up of 3 factors, 2 sine theta and cos theta, and we've got one term on the bottom consisting of 3 factors as well, a 2, a cos theta and another cos theta. And so we can cancel out common factors. 2 into 2 goes 1, 2 into 2 goes 1. We can cancel out the cos theta with one of the ones here, so we can just remove that too. So you see we've got sine theta all over cos theta, and you could write that in if you like, sine theta over cos theta, but at the end of the day sine theta over cos theta is identical to tan theta. And if you wrote LHS here, then do make sure you finish with is identical to RHS, okay, the right hand side. Anyway, that's the style that I would answer this in, okay.